So we know about the rectangular coordinate plane. Now we're going to take a look at the polar coordinate plane. And so in rectangular coordinate planes, we have x and y values, and that's how we plot our points. For polar coordinates, the r, or the first value, is the distance from the origin. And then the second value is the angle, the amount of rotation that the point is going in. Okay, and it starts at the polar axis, which is where we would have our initial side when we were looking at the rectangular coordinate plane with our trig. And so you can see where this relates to vectors, because we have an amount of rotation, and we have a direction there, and then we have the distance, which is like the magnitude of your vector. All right, so for example number 1, we're going to plot the given points in the polar coordinate system. So for part A, we have 3, so that's the distance from the center, from the origin. So we're going to go out to the third ring, and then we are going to rotate at an angle of negative, so we're going to go clockwise from 0 degrees, pi over 3, which is the same thing as 60 degrees. So we come out here to that third ring, and we're going to rotate down 60 degrees, and so our point is right there. And that is all you do. So for part B, number 2 means we come out to the second ring, and then we're going to rotate pi over 6, which is 30 degrees, and so our point is going to lie right there. And then for part C, we have 2, so again, we're going to come out to the second ring, and our angle is negative pi over 6, so it's like negative 30 degrees. So we go clockwise, and there is our point. So really, you don't have to draw those lines and arcs. You can just plot the point if you want. I just did that to show you what I was doing. All right, let's take a look at the second example. Plot the point 2, 5 pi over 6, and then we're going to find 3 additional representations for that point using negative 2 pi to 2 pi. Because really there's an infinite number of representations for any point on the polar coordinate plane. And so we're going to start at the origin, come out to the second ring, and then we are going to go 5 pi over 6. So if you remember, 5 pi over 6 is 150 degrees. So we're going to rotate all the way around to 150 degrees, and there is our point. So basically, we are looking at, okay, what angles are coterminal with that? And then what would the x value be? So if I stay with my positive 2, and I'm going to change over to red here. If I stay with my positive 2, that means I'm out here. But if I go the opposite direction, then that is going to be negative 7 pi over 6 will be that angle. And so notice that is between negative 2 pi and 2 pi. Okay, so that takes care of the points that have a positive 2. Now let's take a look at what the points would be if we had a negative 2. So we're going left out to that second ring, and then we could go up. Okay, and so that's still a negative direction for an angle because it's clockwise, and so we only went pi over 6 radians there. And then we can also, again, we could go out to that negative 2, and then we could go counterclockwise, which will be a positive angle, and that positive angle, again, we had negative 2 for the x, or for the r, and then that positive angle has a value of 11 pi over 6. And so that's 3 representations that would be where theta is between negative 2 pi and positive 2 pi. But they all represent that same point. Okay, just like our coterminal angles, they all landed in the same spot. It was just different amounts of rotation, different directions of rotation, that kind of thing. All right, so let's take a look at coordinate conversion. And so we have this diagram here, and you can see that if we have the x and y axes, your polar axis is the same as the x-axis. And we are now calling, so the polar axis and the x-axis are the same. The pole and the origin are the same, okay? And so now, instead of having our x value, we have an r, and instead of having our y value, we have a theta. So if you look at this, your cosine of theta is equal to x over r. So then if we multiply both sides by r, then if we multiply r times the cosine of theta, we get x. And then we can do the same thing for our y value. If we want to convert from polar to rectangular, we know that the sine of theta is equal to y over r. So then r times the sine of theta is equal to y. Okay, and so you can see these on the next page. If we want to convert from polar to rectangular, we have those two equations that we just found on the other side. And then if you want to go from rectangular to polar, remember that we can use the tangent, so y over x. And then we also know that we're making right triangles, so we can use Pythagorean theorem there to go from rectangular to polar to find our theta and our r value. So for example number 3, we are going to convert the point from polar to rectangular. So we know that x is equal to the r. X is equal to r times the cosine of theta, which was 3 pi over 6. So when we do that, we get 4 times really the cosine of pi over 2, which is just 0. So 4 times 0 is 0. And then we have y equals 4 times the sine, and I'm going to say that's pi over 2 because it's the same thing. And then so that sine of pi over 2 is 1, so that would be the number 4. And so we get the 0.04. So that's our answer for that one. For number 2, we are going to, again, take x equals r, which was 2, times the cosine of pi over 6. Well, the cosine of pi over 6 is square root of 3 over 2, so then your 2's are going to cancel out. It's like 2 divided by 2. And so we get square root of 3 as the x value. And then for y, again, it was r times the sine of pi over 6. And we know that the sine of pi over 6 is 1/2. So half of 2 is 1. And so we have the point square root of 3, 1. All right, and then for example 4, our last example, we're going to convert from rectangular into polar. And so we know that tangent of theta is equal to y, which is 2, over x, which is 2. So the tangent of theta is 1. And since this is in the first quadrant, we know that theta has to be pi over 4 because that is the angle that has a tangent value of 1. And then we also know that r squared is going to equal x squared plus y squared. So r squared is equal to 4 plus 4, which is 8. So r is equal to the square root of 8. Again, it's a distance, so it's not going to be negative. We only want the positive. And that can simplify to the square root of 4, which is 2, times the square root of 2. And so our ordered pair would be 2 square root of 2 and pi over 4 would be the point on the polar plane. All right, and then for part B, again, we're going to take tangent of theta equals 0 over -1. And this one's kind of a trick question because it is on the x-axis, so it's not actually in a quadrant. But the tangent, the point -1, 0 is at the angle pi. And then again, we can do our r squared equals x squared plus y squared. So here r squared equals 1, so r is going to equal 1. So we have the point 1 pi. And that is how you can convert from polar to rectangular. and rectangular to polar.